Good afternoon, everyone. On behalf of CPI Industry and TEVMO, I would like to welcome you all to this webinar in which you will learn about cooling load calculation made easy by this revolutionary technology presented today by TEVMO and Mr. Victor and his team. So thank you very much for joining. I would like to remind you that upon completion of this short webinar, you shall be entitled to a free pilot project, and feel free to reach out to Mr. Victor for the details on that. And I would like also to thank Proleed Engineering Consultants, who has been working very tightly with us on making this webinar happen, which we hope will be useful and fruitful for all of you. So I shall hand over now the microphone to Mr. Victor. Hope you enjoy it, and I shall see you again at the end of this webinar. Thank you very much again, everyone, for joining and taking your time to attend this webinar. Thank you. Victor, over to you.
Thank you, Frederick. Thank you, Frederick, a lot. My name is Victor. I'm from a company called TEVMO, and I'll share the screen now to show you the presentation. So as Frederick already said, the name of our webinar is Cooling Load Calculations in Revit Made Easy. I'll start immediately, and in the end, I'll tell more about who we are and what happens. So first of all, we only consider the situation when you have a BIM file in Revit. So what we are talking about today is about calculating cooling loads in Revit. So the first, what you need is architecture and structure in Revit. Then you create a HVAC Revit file, and link your architecture and structure. If you work, if your engineers work in Revit, not only architectures, then probably you know this part, and you always link the architectural file. The thing is that our plugin, our software, it works with HVAC files. So you don't need to change anything in architectural structure. You just need to make some changes in Revit in the HVAC file. Then the best thing of our solution is that all the surfaces, information on all the surfaces, is collected automatically by the plugin, by our software. The only thing you need to add manually is information on lighting, on electricity, on people, on infiltration. So this is the same as you do in many different applications to calculate cooling loads. But the thing is that the most difficult part is to calculate, to automatically collect surfaces and to input information on surfaces, on ceilings, floors, slabs, doors, windows, etc. So this part our software makes automatically for projects in Revit. But as you see on the slide, the information on electrical devices, lighting, people, infiltration, you still add it manually into the spaces or rooms. Then the best thing of our software is that we have 3D visualization for everything. So you press one button and you get an so-called energy model of your building. Probably many of you know that there is an energy model collected by Revit itself, but the best thing in our software is that it's really quick. So for this project that you see now, it takes less than a minute to collect energy model. So you can easily collect energy model, see if everything is okay, and if something is wrong, you can easily change it. Now, after you collected the model, our software automatically adds so-called user surfaces types and shows it to you. So you can click any of them and see, for example, if all windows are there and that all these windows have the correct U value, for example. So it's very easy to do that using this 3D model. Now, after you make the calculation, it's very easy using our software to check that the calculation was correct. For example, here you see that floor is mostly light red. Light red means that there is less cooling loads than for windows, for example. You see they are more red, and some windows are more red, some less red. So again, you quite easily understand that all the calculations are accurate. But for sure, you can click on any surface and see the real values. Now we have the same visual report for other types of calculations, for example, for electrical devices, lighting, people, and filtration. For example, you see the red room, this one, it's more red than other rooms. It's because it's some kind of spot activity there. And you can easily check that you haven't forgotten anything. And for sure, we have all the reports. So our calculation is HRI calculation. And as you for sure know, there are many different methods in HRI textbooks for calculating cooling loads. So the most known are probably RTS, radian time series, the one that we use. And another one, transfer function method, is also very known, and heat balance method is also very known. So there are a few of them, the most used ones, and I'll discuss it a little later. The one that we use, the one that our that other software uses, yes, and I'll discuss it later. Now I'll show you the video, a short video. It's the first project. I'll show you how everything is done from scratch. So first we create the HVAC file. If you work already in HVAC file, if you have some spaces, no need to create it. But here I show how to create it. After you create it, you create levels. The levels come from architecture. So here you see the levels. So we, in fact, copy with one button, we copy the flows from architecture. Now we add some parameters and input calculation settings. So for example, TEVMO shafts. We put 35 degrees for shafts because shafts are automatically, our software sees shafts automatically, and you put 35, for example, and make it unconditioned. So now you put the typical levels, so that not to calculate all the levels of the building, you input the typical levels. It has been shown now. And now you say that you want to create spaces by rooms. So we had rooms in architectural files, and we created spaces based on those rooms. Now you can group several spaces into a system and add the parameters for electricity, for lighting, etc. It was shown now on the left. After that, you make the calculation. So you, after that, now you copy all the spaces to typical flows. And now you collect the model, the energy model. So now let's see the energy model. This is how it looks. It shows only the untypical flows. So no need to show the typical flows. And here you see the flows that are not typical. Here we selected one space, for example. And now you see the list of automatically created user surfaces types. So for each user surface type, you can easily click on it and see, for example, all windows, all slabs, all roofs, etc. So it's very easy using this software to check that all the information was collected correctly. Now imagine that you want to add one more surface type with one more U value. So this is how it's done. You just add a new string. And here we show how to add, for example, a window with shading. Now you select on the model, just on our 3D model, the windows that you need to change U value, not just U value, but to put a new type for new surface type for these surfaces. And you select the surface type we've just created. So for example, we created it with windows with shading, and now they are there. So now just usual windows, they are not here anymore. And windows with shading, you see all of them. So again, you can easily check that you haven't forgotten anything, that your values are absolutely correct for each surface. Now we push the calculate cooling loads button. So the calculation has finished now. And we have one more report, again, visual report. For example, here, as I told you before, the more red the surface is, it means that there are more cooling loads coming through this surface. Again, very easy to check the correctness of the calculation. What is shown now is that all the information on cooling loads is there. Just click on the surface and see all the information. So this is kind of report and report to check that everything is correct. Now we download a report in Excel. So you see this is how the report looks. So some basic table with all the levels, and the typical levels, they are grouped as you see. Usually you do it like this, I'm sure. And basic information on the whole project. And then for every zone, you see zone or system, how do you call it? You see more information. Now, a very important thing. Here is our report in GB XML format. This is done to easily move all the data to, for example, HAP. And this is a small comparison of one space. Just you move this data to HAP. You can calculate it in HAP easily. You don't need to do much more in HAP after that, because all data is already in HAP. And here is our calculation. You see the comparison with calculation in HAP. So everything is there. The values are almost the same. As I told you, so the total is 1,500 and the same in HAP. As I told you, this HAP file was made automatically. So we input to GBXML, export to GBXML format, then you open this GBXML file in HAP and you get this result. So very easy to compare. So that was the first project that I showed you, and now I'll show you some of our portfolio so that you see some projects that were made using our software. So I'll just show you some pictures so that you can just see this. So it's all in our software, how it looks in our software. Very different kind of buildings, very different kind of buildings. Like this, like this, like this. This one. So really a lot of projects have been already made in our software. And as you see, it's quite easy to understand that everything is correct. For example, you can see that yellow surfaces, it means that the surfaces are between something inside and something outside. So there is some air conditioning. There should be some air conditioning. You just need to understand the colors, and then you can view the model and easily analyze if it's correct or not. So some models are bigger, some are smaller. As I told you, the good thing is that our solution is quite fast. In our company, there are a lot of mathematicians, so we are very good with algorithms, just very basic, good algorithms of, to work with big data, to work with a lot of data. And we do it really fast. We automatically, manually, automatically compare if some surfaces are parallel, if they intersect, etc., and make it really fast. That's why you can work with some big projects in our software. So very different kinds of projects were done in our software. You can see here several houses, buildings, yes, and they can be considered as one building in our software, or you can consider each building. And as I told you, all these buildings, the basic models are in Revit. So every project that I show you now, the original file, BIM file, was a Revit architecture and structure file. Okay, so there really a lot of projects have been done in software. Now I'll show you one more project, and in fact the video that I'll show you now will be just the same but on a different project, so that you better feel the software. So I'll say almost the same words but on a different project. So yet again we start with a new HVAC file, and we link the architecture and structure files. So you see this is some different project. Now we created the levels, the same as we did last time. You see the levels. Now we attach parameters that our plugin needs. So it just adds some parameters to families in Revit, etc. Now we input some basic parameters of calculation. Yet again, we set, for example, temperature for shafts, and we add some more parameters. Now we create spaces. Okay. So now we automatically created spaces. There is a special button in our plugin. And now for the spaces, we input the parameters I was speaking about before. So we group the spaces into one system, also called zone, and now input the parameters on electricity, on people, etc. After that, we push the collect energy analysis model button, and now show energy analysis model. So this is how it looks. After we inputted all the parameters, this is how it looks. Again, we can choose any system and be sure that it's correct here. Now, again, we see a number of user surfaces types. As I told you, they are created automatically, and some basic U values, maybe for Dubai, yes, they are put here automatically. But you can both change U values, you can change types of surfaces, and you can also add new ones. This is just for convenience. And you see, when I choose different, the 3D model changes, and you can be easily sure that all the walls were collected correctly. And all the walls that you want to have some U value and some type, they are there. Now we add again one more user type surface, change window type and add some shading. And now we want to select some surfaces and make these surfaces this user type. So before they were just window assembly, but now we added window assembly with shadings, for example, and we make them this type. So it's very easy. You select what you want to change and you just change. After that, you can view on the 3D model that all the changes were correct. So you don't see these windows here anymore. You see they're absent now. But these windows are now have a different U value. And in fact, they have different type. Now we are just calculating cooling loads. Now we view this energy model again and show the report. You see those windows, in fact, they are with shading, but they are more red. It's because we choose a different type. So these windows are more cooling loads go through them, even though we added shading. It's because we choose the different type of windows. They are simple windows. So with just checking the colors, you can easily understand that everything is correct. You see all the shafts. If you input the shafts manually, you can easily forget anything. But here you can easily analyze and see, okay, all the shafts are there. They were corrected correctly, and you might be sure that the report will be correct. So this is already the report. Again, the first page of the report is just some total information for each floor, and here is information on every zone or system. This is again export to GBXML file, and now we again will open this GBXML file in HEP. So this is one surface, one room, one zone, one space in HEP, and this is the same space in our software. And yet again, the values are very close. In fact, it's a little bit different just because when we export to HEP, HEP doesn't understand partitions. So you can easily see that on the left, in our software, the cooling load for partition is 177, and the automatic export to HEP, it loses the partitions. I don't know why HEP doesn't read partitions from this GBXML file, but it's how it is now. So, but the values are almost the same. If you minus these 177 from HEP value, from our value, you'll get almost the same values in HEP. So let's continue. In fact, now I showed you two projects just to feel the software. I showed you also our portfolio, and now I'd like to give a word to Prince. He is from Proleed, the engineering consultant company with whom we made one project. In fact, not made, the project was calculated first in HEB, but we made the comparison. So we calculated the project in our software, and we compared it to their calculation. So please, Prince.
Hi, Victor.
Hi, Prince.
Yeah, hi. Let me share my screen once.
Okay.
Victor, hope everyone can see my screen, right?
Yes, everything's good.
Yeah. So thanks, Victor. Thanks for the invite for this webinar. Hi, good evening, everyone. This is Prince from Proleed Consultants. I'm working as a mechanical engineer for the past few years with Proleed. So today we are here in the TEVMO webinar to share our experience on running the software in in the TEVMO plugin software. Yeah. So as an MEP consultant, we Proleed are introduced to a new Revit plugin software named TEVMO, designed for cooling load calculation for all types of building in Revit. So basically, as an MEP consultant, we are currently working with Carrier HAP software to obtain the cooling load calculations. So it was a great opportunity for us to understand this plugin software, how much it will differ from how the way we work in HAP. So I will share a few of my experiences on that. Prior to that, how we have did our first run of the plugin software is basically based on the manual videos shared by the TEVMO team. So we have selected one of our ongoing project in Revit, which is a G plus podium plus 5 residential building. And one thing what I have observed is like basically the inputs are being taken from the Revit. So the TEVMO Revit plugin software will be very user friendly for the engineers who used to work in Revit, though it can be managed by the ones who are not much familiar with Revit also. Basically, I am not much a Revit professional, but I managed to run through the plugin software and obtain the cooling load calculations. So I can share few of my observations and key points which I have seen in this demo. So one of the main key points of this demo plugin is the building envelope input parameters like external and internal wall areas, all the fenestration window areas, building roofs, floors, identifying the internal spaces like bedroom, living spaces, common areas, all will be taken automatically from the Revit by the software. So that is a great advantage for the designers for the cooling load calculation, because basically the user's interference on collecting this information, the building envelope informations, is very less from the Revit file, which is a great advantage. Basically, why I say, because as a HAP user, I spend around like 18 to 20 hours 20 hours of time to do the same kind of a project only on the building envelopes, which is the main parameters for the cooling load calculation. For which here I need to spend around, as it's my first run, like I had to spend around like half an hour to 1 hour, which is really a time saving and really quick. So I appreciate that. And it automatically detect the corner spaces and also display the shafts, as rightly Victor said in his presentation. But again, what I have found is like it was detecting the balconies also as a space, which may be the corruption from the architectural Revit file. Again, we may have to manually delete those balcony spaces, but it's very few, maybe one or two balcony. I found like one or two balcony spaces were considered as a space, which I manually deleted from the space option given in the Revit in the plugin software. Sorry. So that a TEVMO team has to work on that. Again, another key point I have observed in the during the run is like the internal load inputs such as lighting load, equipment load, number of people, set point temperature, basically the characteristics of the room, internal loads. So in Revit, we need to punch in these numbers as normally we do in HAP. But what is the advantage I have found is like we can the internal load inputs for all the typical spaces for all the apartments can be punched in one go. It's a big advantage of the software. Basically, if you most of them are doing calculations in HAB, you may be knowing that for a typical apartments, all the living rooms or all the bedrooms will be having the same input parameters, right? The internal load input parameters. For instance, if it's a bedroom, all the bedrooms for all the apartments will be having the same lighting load, same equipment load, or even same number of people we are considering as per ASHRAE. In HAP, we need to go one by one. We need to plug in, or like we have to punch in all the numbers individually to all the spaces. Whereas here, uh, it's with the help of Revit, like we can select all the typical spaces like bedrooms, and we can punch in all these numbers in one go, so that the Revit plugin software can intake these to the for obtaining the cooling load calculation. That feature, which is not available in the app, seems to be very impressive in plugin software from TEVMO. Then comes the show energy analysis model option. So this is a very basic feature which you can available in Revit also. But what is advantage is like we will be having a fast construction energy model to validate that all the building envelopes we have considered in this project are taken into the calculation or not, because the user engineer get an overall idea of the building envelopes like walls, windows, slabs with proper color indication, and cross check and make sure that all these parameters are considered. Basically, in HAP we don't have this kind of a feature. For instance, if there is like 590 or 600 apartments, and there will be like multiply by 2 or 3 number of windows, there will be like 1,200 windows will be there for one project. So there are easy chances that we could miss 2 or 3 windows in this project. But whereas when we are working with TEVMO plugin software, what I have observed is like this particular feature, show energy analysis model feature, will clearly indicate how much windows you have selected, or which from this picture itself on the left corner, from which we can understand that which windows we have missed out. So in this ongoing project, which is a live project in Dubai, all those red are the windows, and all those blue are the curtain walls, which is covering up in the retail spaces, and so as double height spaces in the ground floor. So this feature seems to be very impressive, and which reduces the mistakes happens in terms of taking the building envelopes. And coming to the final output files, the cooling load calculation outputs, and it can be generated in a normal standard Excel format. Okay, with an easy demonstration of the total cooling load summary for the building. It's all about, after obtaining the cooling load calculation, we have to just push this button, which is available in the plugin software, which is download cooling load Excel report, which rightly shown by Victor on his presentation, will give you a Excel report in the format which is being given on the bottom. It is really convincing and well formatted, I should say. So we could easily access the total airflow, the sensible load, total TR of the entire project from this. So as we will be having the individual system summaries as well, which I'm not put it over here in this presentation, but it is still available. So this is a particular Excel format. This is the output cooling node output summary generated for the the first run like pilot project which we have executed. I can show you the comparison sheet between what we Proleed has done with HAP and what the result we have got with the TEVMO plugin software. On the left, if you see in the blue, which is a HAP cooling load summary, is being calculated from Proleed, and we have come across 184 TR supply load for this entire project. Whereas when I've been trying with this TEVMO plugin software, the same software output results comes around like 181 TR, which seems to be very close to our HAP calculated load, in which we spend a lot of hours, whereas here we didn't spend that much hours. Like it's very quick and fast. So the difference of the total cooling load summary is very less and almost the same, with a plus or minus 5% difference of each system I'm speaking, like individual FCUs. In terms of FCUs, if you look into it, it will be having plus or minus 5% of difference, which can be which is okay, which is negotiable. Like again, which is to be looked forward by the TEVMO team to improve. So coming to the conclusions, so as per the results obtained for the first run, that the building envelope inputs computed and taken, it seems to be very correct. And TEVMO team have to do further studies for implementing the software into the market with local complaints and authority approval. As all of us know that HAP is approved by the DM, by municipality. So it's that implementation of the software with approval from authority, it's a big task for the TEVMO team. And accuracy of this HVAC plugin software, we have checked with one of our live projects. So the same to be checked at different levels of projects to validate the correctness of the software, like different applications like retail jobs, maybe a mall project, high-rise buildings, and hotel projects, which we have not carried out. So that is all to be validated for the correctness of the software. And to reach to all the beginners of the software, a well-organized step-by-step tutorial manuals to be prepared from the TEVMO team, so as everyone can access and experience this plugin software. So that's it. Thank you.
Thank you so much, Prince. Thank you so much. Now what I'll do, I'll show you the project that Prince was talking about. So thank you very much, Prince, for your opinion and for your suggestions, for everything.
Thanks.
But before I proceed, there are some questions. One question is like that: if exposed walls and internal walls are not correctly modeled in architecture model, it can be corrected in analysis model through the SAP. So this is a very good question. In fact, I showed you twice that yes, it can. The thing is that first we collect the model, and then you can choose any surfaces you want and just give them a different user surface type with different U value, different properties, with everything different. This is what I showed you in 2 videos before, and please pay attention to the video that I will show now. This is the video with the project by Proleed that Prince was talking about now. So there it will be also shown. So for some particular surfaces, I will change the surface type. So the answer to this question is yes. Now there is some more question. Is the software approved by the municipality, by the authorities? In fact, Prince already answered this question. The answer is for now, no. So for now, it's no. The good thing, there are 2 good things. So first, Prince showed you the comparison with, for example, HAP, and it's very close. It's the first good thing. And the second good thing, I also showed you it in 2 videos before. it's that we have this export to GBXML format that you can read in HEP. So in fact, you can collect all the data using our software with all the pluses that I showed you, that Prince showed you, that you have this 3D visualization, that you can change them types of any surfaces, that you can easily check that you haven't forgot anything. So you can use it, and when you are sure that everything is correct, then you can push this button to export everything to GBXML format, then read it in HEP, and now you have a report in HEP. So you made all the hard work of collecting all the surfaces using our software, and then use HEP to have your reports. So it already works. You can try it. There are some minor problems with that. There are some. I already told you. For example, probably it's impossible, or at least we do not know how to export partitions to HEP. So when we add partitions to GBXML format, HEP just doesn't see them. I don't know why. Probably we just should talk to carrier and ask them. Maybe we don't know how it works, or maybe it's not there. At least we tried it on version 5 of HEP, the most used one, yes, 5.1. It's the most used one in GCC region, yes. And there, this import from GBXML format, so input from our software, it works quite okay, but you need to input your partitions manually. But all the other things, external walls, windows, etc., it's there. So that's the good thing. And in 6th version of HEP, you probably know there is no import from GBXML format yet. So they are promising, they're saying that they will add it soon. But as I know, mostly version 5.1 is used, so it might not be a big problem. So this was a long answer, but the answer is that even while we are not authorized by authorities, you can move all the data after our calculation to HEP automatically and then calculate it in HEP. It also saves you a lot of time. I hope that I answered your question. One more question is how to purchase and how much it costs. So a usual question. We'll soon add the prices to our website. So everywhere you see the website, it's TEVMO.com. Everywhere in the presentation, you see it now again. So please come to TEVMO.com and we'll add the prices there soon. To purchase, you just need to contact us. There are contact information on the website, TEVMO.com. Our company is TEVMO, and company site is TEVMO.com. So you so please contact us. But soon all the prices will be online. But you can contact, and we will just discuss, and you'll understand the prices. Now, one more question about linked files. Where is it? My colleagues, please copy it.
There is a good question about what is the added benefit of the software, because you can export GBXML from Revit.
It's a very good question, but it's a very strange question, in fact. The strangeness in this question is, have you ever tried to collect energy model in Revit? So for those who succeeded, please contact us and let us see how you succeeded. Any big project, even this project, if you try to collect this project that I'll show now and that Prince was talking about, Prince from Proleed, even this project, it collects, the energy model is getting collected maybe for 15 or 20 minutes. On the same computer, our energy model is being collected maybe 1 minute. So it's a huge difference, and one more huge difference is further. So Revit works with, with surfaces that are inside Revit, and we have both surfaces from Revit and user surfaces types, and you can easily connect them. So they are connected, in fact, automatically. You just need to change a few things. So if you ask about importing from exporting from Revit, yes, to, for example, HEP, please contact us, those people who managed to do that on some more or less big projects, even on the projects like I showed you today, and I'll show you now. So this is a good question, but the answer is that at least as we know, it's really very difficult to do that in Revit with this basic functionality. What about us? We do not use this energy model of Revit at all. We started this software, I think 6 or 7 years ago. So our company, our team, it started making software for HVAC about 15 years ago in 2007. So we are quite an old company. In fact, this Dubai company, TEVMO, yes, it's a new one. We opened it last year, but our team and the software has been developed already for 15 years. So we've done really a lot of software for calculating different equipment, air handling units, chillers, fans, VRF systems, etc. So many tens of thousands of calculations of different kind of equipment, ventilation and air conditioning equipment are done in our software every day. Tens of thousands of calculations. Thousands of people are working in our software every day. The thing is, what I was talking about, that we started 6 years ago with this project with Revit, and all these years we saw many different projects in Revit. In fact, you know, many architectures, they even don't use this multi-layer wall. So they just make walls out of several walls put together. Try to calculate energy model for such a building in Revit. It's just impossible, because Revit will see only those walls that are near the space, and it won't see other walls. And in fact, there are so many such small things that make it very hard to use the basic functionality of Revit to build energy model, and then to move the data to GBXML format, and then to read it in HEP, for example, HEP in trace, etc. So the answer is very easy. The benefits of our software in comparison with the basic functionality of Revit for collecting energy model. And I tried to tell you. But if you have some more questions, please contact us. I'll tell you maybe 20 or 30 reasons and the difference between our calculation and the basic Revit calculation. Then there was some more question. Yes. What is the architecture model is linked to HVAC file? Will the changes get referred to matter? Yes, that's also a very important thing. For sure, a very good question. And the answer is yes, for sure, yes. No one will use the software if this question, the problem wasn't solved in this software. The thing is that on our experience, as I told you, 6 or 7 years experience already, most projects pass this way of that architecture is changed from time to time. So every second month or every second week, the new architectural file comes. The good news is that you just calculate it, link a new file, again calculate it, and those spaces and all the information that stayed, that wasn't changed, it remains the same. And you don't need to recalculate it or do anything else. But where there were some changes, yes, you need to add some more information. For example, if you got one new floor, one new level, or if you got some new spaces with some new people, or if the amount of people changed, or some electricity changed, or some surfaces changed, yes, then you need to adjust only this part of changes. So I hope I answered also this question.
There was a question about the certification from Ashraya.
But I already answered it.
No, you answered about Dubai municipality, and this one about...
Okay, yeah, correct, yes, correct. For Shai, also, no, not yet. But the answer, in fact, is the same. For example, you can use our software just to make it much more easier to collect all the surface information in Revit. and then use this GBXML format ready to be read by HEP. So you know how it usually is. So for example, HEP, I say HEP, it's not only HEP. For example, Trace also has it, yes, and the Elite program you certainly know for cooling loss calculation also has it. So GBXML format is such format to move data from one software to another software. But the thing is that I see one more question. The thing is that when you use this software, then usually those who write the software, they write software, they write this GBXML format things for their software. But what we do, for example, in this region, we understand that, okay, HEP is the most popular, as we see. So HEP, maybe I'm not correct, but please tell me, as I see now, HEP in this region is most popular for calculating cooling loads. In that way, we try to compare everything with HEP, if it's the most popular. And as I told you, there are some things with GBXML that are not standard for all the software things. So here we have Revit, okay. We collect all the energy model by ourselves. I mean, our plugin, yes. Then we put this information in GBXML format, but in the way that HEP really understands. For example, HEP has still, at least HEP 5.1 had some problems with importing Windows assemblies from GBXML file. So you could import only as one assembly, and if you added several assemblies, there were some problems. In the later versions of HEP, they solved it. But knowing this problem, we put all the information in the GBXML file the way HEP knows how to read it. So we work both with Revit and with the solution we want to put data in. That's why, again, the answer about ASHRAE, about Dubai municipality, Dubai authorities, yes, is that you can use our software even with HEP together. So Revit, our software, HEP, and it will save you a lot of time. Though we always check that our calculations are as correct as, for example, in HEP. Okay, I wanted to tell you more about some methods. Maybe it's interesting. So you probably all know that in ASHRAE there are several methods, and as I told you, the most popular are, for example, RTS, radian time series. So this is the method that is a basic method of calculations in our software, in our plugin. But transfer function method is also very popular. And it is used by HEP, for example, but by HEP till 5 version. In version 6, they already use another method called heat balance method. So, even one software, for example, HEP, one version uses one method of calculation, another version uses another method of calculation. And the results, they anyway differ. You understand? So the way how we work is we try to understand what most of engineering consultants use. Here, I think, as I told you, it's HEP 5. We will make it, we already made it really close their answers to this method. So, or to the HEP 5. So for GCC region, we use in our plugin this transfer function method. The same that HEP 5 uses to make the results very similar. Okay, Rustam, more questions?
Yes.
About trial version. Yes.
Trial versions and version for students.
Yes, trial version for students. The answer are very easy. The answer is easy. Trial version, of course, you receive a trial version for 2 weeks. It's just everyone who asks, he can get this trial version. It's easy, but you certainly should tell us who you are, what's the company. So answer some questions, and only after that you get this trial version. But the thing is that the questions are very easy, so just tell who you are and why you need the software, and you'll get the trial version. The good thing Frederick talked about today is that trial version is, not really okay. Trial version, you can try it, but the good thing is for those who visit this webinar, we make pilot project together. So we not only give our software, but those people who are on this webinar, yes, they can ask us for a pilot project. So that you can give us a project, and we make this project. At least we not make the project, but we show you, and we can write a video for you how to make the project, your project in our software. So this makes life much easier. For example, Prince from Proleed told this just now, that we together made this pilot project. Yes, so he had some. This project was calculated already in HEP, but we didn't ask him to do a lot, because we understand that all engineering consultants have many things to do. In fact, yesterday, not today, not tomorrow, but yesterday, they have to do many things. It's always like that. So for those who are here on the webinar, we'll do the pilot project together. So you can give us your Revit project, and we'll show, write videos for you, some kind of manual on your project, so that it takes really a small time for you to check that it works fine. So the answer is, for sure we give trial version, but the good thing is that for visitors of this webinar, we also give a pilot project. We also help to make the pilot project. More questions?
Here, Jihad Naji said that the problem with partitions is that in HEP it is a Revit button. And he also said that it's a problem when exporting GPXML with multiple walls located together, staying together.
Yes, okay. Okay, partitions are not recognized because it's a radio button option on HEP. Okay, I see your answer, but in fact it's strange, because partitions in HEP are in fact they look, at least in HEP, the same as all other surfaces. And why partitions? There are also some problem with floors. So all the internal walls, surfaces, for some reason, HEP doesn't understand them when inputting from GPXML. Just, we would be happy to talk to you personally. And if you have some more ideas, we'll discuss them. The solution is to simplify the architecture model. Yes, that's what I was talking about. Yes, you're correct. So we know our Revit model very well, as you understand, because we create our own energy model. So we can simplify the model and do all the correctness inside our software, so that all the data goes to HEP the way that HEP understands it. So even in this way, we make the life much more easy for engineering consultants. Okay, more questions? No more questions, I think, yes?
Mm-hmm.
Okay, thank you so much for your questions. And I'll show you this last video I was talking about after Prince from Proleed discussed our software. So share screen, and here it is. Share. So yes, this is the project. Oops, right. Okay, I especially did it this way. You know, I showed you one video showing you everything in showing you how our software works on one project. Then I showed you a second video so that you see how the same software works on another project. Then Prince told us his opinion on our software. And now I'll show you already the third time the same things, but already on the project that we that we calculated with Proleed. So here it is. And now you'll see once again, in fact, answers to many questions that you asked. For example, the answer to the question, how can I assign new surfaces type to surfaces that were incorrectly set in architectural model? So let us see again. Okay, why not? Sorry, okay. So again, we create new file, HVAC file, and create links and link here architectural files. There was a question, good question, if architectural files change, please link a new architectural file. Now we collect levels from architecture, but in fact, if there are new levels, then new levels will be inputted. If there are no new levels, that nothing happens. Now we import some parameters. Again, shafts are being recognized automatically, and we put 35 degrees for shafts. Now we work with typical flows. And there was one question about Revit. Again, it's a very important question. Try to collect energy model in Revit if your model has typical flows. You'll get some big problems with that. So in fact, it collects the whole building, yes, and builds energy model of the whole buildings. And in our software, I just showed you, yes, you select the typical layers, the typical floors, the typical levels, and you do not need to input information on them, and the calculation is much faster. So our calculation and the energy analysis, in fact, is done for the floors that are not typical. So it's also a big, big benefit. It saves a lot of time. So now we create spaces. In fact, there are several options to create spaces, and this option is create spaces by rooms. So the spaces were in fact copied from architecture. Again, if your architectural file has changed, the spaces or the rooms there, most of them, they didn't change. So if all the rooms in architecture they change, in fact, it's a new project. But mostly, yes, only some, there might be some new rooms, or in old rooms, some surfaces are different, or some windows are different, yes, and this works okay with the method that I show you. Now you saw, now let us see. So yes, here, in this project, I show a little more. So I show you what happens if, for example, some space is not there. This particular level, it's parking level. Yes, it's a ground floor and there is parking. But here you see that it's not only parking, there are also some conditioned spaces. So parking is unconditioned, and there are also some conditioned spaces. So in architecture, there wasn't a space or a room for the parking. So there were rooms for conditioned spaces, yes, in architecture, but no rooms for parking. And we add this, you need to add manually, but have a look. Yeah, sorry. Yes. So we try to add a space, but Revit doesn't want to do that. And here we just add separation line. So this functionality of separation lines is very used by our software. Our plugin really works good with separation lines. And for example, if some space cannot be put in Revit, you just add separation line and that's it. So you need to input some more spaces, that's okay. Then you need to choose all your unconditioned spaces on a floor, on a level, and okay, like this, and then set some temperature for them. So for example, here in this project, it was 35 degrees. So we put here 35 degrees, and we put this, we check this box, so it's not, so that this space doesn't get into these spaces do not get into the reports. And now this part you already saw. After all spaces are okay, you just enter the properties for the spaces, for the condition spaces. So you group them into zones or systems, like the way you want to call them, and add some information on equipment, on people, on lighting, etc. So here is the example on 2 spaces. For sure, you do it only on typical spaces. After that, you push one button, copy, create spaces on typical floors like this, on typical floors, and the spaces created there automatically with all the parameters already set. It's shown that you have all the parameters. Now we collect energy model. As I told you, it's not energy model of Revit. It doesn't in any way, it doesn't use energy model of Revit in any way. We collect our energy model. We just analyze all the surfaces and check if they are parallel or intersect, etc., and make the model. So here we choose the zones, and you can easily see all the zones. There's also search inside this 3D model, so you can easily find all the elements. And yet again, see this is the list of automatically created user surfaces types. So if you open in this plugin, you can easily open the table with inputted surfaces types. And usually in Revit projects, even in this one, there are hundreds of inputted surfaces types. But no one, in fact, works with such a big amount of inputted surfaces types with all of them. And this is also our great benefit. Someone asked me about Revit calculation. Yes, when you try to work with Revit surfaces types, with all those hundreds of surfaces types, you just can't understand what's important, what's not. Yes, and with our 3D model, you just press one button, you choose the user surface type, you press this button, and you see all the elements with this type just on the 3D model of the building. As I say, as Prince said before, as an engineer, it's very, very convenient. It saves you a lot of time. And this is one more method. You see, it wasn't shown in previous videos, but it's very important. In previous videos, I showed you how to change some surfaces on the 3D model. So you choose the surfaces on 3D model and assign them a new surface type. But there is one more possibility. You can the table that is open now is the table of all surfaces type inputted from Revit, and we filtered now in the search by curtain. So curtain was a wall in Revit. I also answered this question already. So it was a wall. And have a look how easy we can assign a new element type to all walls, or to all curtains, for example. So have a look. We just input there our user elements type for each curtain Revit surface type. Then we again press show energy model, and you see it. So they appeared here. Before there was the curtains, they were not here. We've chosen window assembly with U value 1.7, yes, and they're already here. So this is how easy it can be done. And now I'll show you the second way. So we create a new surface type, user surface type, for example, window with shading. And now we just select some surfaces on 3D model. It can be windows, it can be anything. And assign them a new type. We've just created, for example, window with shading. Okay. Now if we press, you see that this type, this U value and other information is only assigned to these surfaces and not to other surfaces. Now we calculate cooling loads. After we've checked everything, it's easy. And this, as I told you already twice or three times, this is also a very important thing. Yes, you see, in fact, it's a kind of report. So you see the color of the walls, and you understand that generally everything was calculated correctly. that windows are more red, in fact, that walls, that you didn't input some incorrect U value, for example. And you see that all the shafts are there, all the walls, you can check all the values of cooling loads for them. And this, okay, and what's important that this floor, it was the ground floor, oh, sorry, that was the ground floor, and that was the ground floor. And you see that here it's different color, the walls are different color. That means that this parking, it's unconditioned. So you don't see the parking, but you understand that it's not a street there, but there is some unconditioned space. And when you press the wall, you see that this unconditioned space is 35 degrees. And in this space, there is some different temperature. So easily check everything. So here you see the area, the temperature on one side, on another side, everything. Here you see the floors, okay? So under this first floor, there is parking. So all the floors here are red. This is because under these floors, there's unconditioned space. But somewhere you see white, it means that there is conditioned space underneath. And here you saw that all the floors were white because they are under this floor, there was conditioned spaces. So very easy to check everything. So I think that's it. TEVMO is our company. You see it on the screen now. Our website is TEVMO.com, very easy. In fact, TEVMO name, it's because we always write software that deals with temperatures. And TEVMO means temperatures, it's T-E. V is variations, and MO modeling. So temperature variations modeling, our company name. Because all the 15 years we deal with, we write software that deals with temperature variations modeling, in fact. And our website is TEVMO.com. So please come to our website, and there are contacts, and please feel free to contact us, write us an email or contact us through WhatsApp. And ask any questions you want. Okay, so you understand how to find us. Now about this webinar, yes? So, okay, cooling load and calculations in Revit made easy. I hope I answered this name of webinar and some bullet points. Yes, 7 man-hours on every project. Okay, Prince spoke about that. I spoke about that. Hope you understood how our software saves your time. Then achieve highest calculation accuracy. Again, this 3D model, this 3D visualization, the way how you see the calculation results, the way how you see the results of the collection of surfaces from Revit, it makes the calculation much more accurate. So hope I answered this too. Then save time on each project recalculation after any architectural changes. Yes, that's very important. We had already this question today. And yes, it works, and our plugin wouldn't be used otherwise. No one wants to input all the data one more time after each architectural change. And what's more, software is suited to Middle East conditions with local support. So it's also very important because, you know, support nowadays, support of some software is crucial. In fact, the thing is that our webinar today is for GCC region, yes? Our TEVMO company is a Dubai-based company. So it's registered, it's license, it's Dubai company, yes. But now our greatest idea, yes, is to understand everything is in this region. And for example, I myself, I live in Dubai. So I myself can come, I'm a CEO of the company, of TEVMO company, and I myself can visit your office here in Dubai or anywhere in GCC easily. If you have some questions, it's really much easier to solve any questions when you are in the same region as your customers. So I think this is a very important point. That's why I wrote it here as a bullet point. So that's it, Frederick. I hope that everything was understandable, and I give you the word.
Thank you very much indeed, Victor, and everyone for joining here today. We had expected about 50-minute interaction and we went over 1 hour, so this is great. Thank you very much for your very comprehensive presentation. And obviously feel free, everyone, to reach out directly to TEVMO should you have any specific question, and to claim obviously your free pilot project.